All right, so we are in geometry. Today's date is Thursday, January 30th, 2020. 5-4, trig ratios, finding side lengths. You are now officially in trigonometry, and trigonometry never, ever goes away, ever. Sorry. So trigonometry comes back to haunt you in Algebra 2, in pre-calculus, in calculus, in higher level math classes that you take in college. It is very useful as a tool, especially when it comes to mathematics. Maybe not so useful when it's in the real world, unless you're like maybe building a house, I suppose, and you need to figure out some lengths of triangles, and maybe even non-triangles too. But let's go ahead and define some things. Before we do that, our objective today, Julian.
Use trigonometry to find missing side lengths of a triangle.
Exactly. So if you can do the objective, that means you can do these problems where I say, hey, I give you an angle, I give you a length, and you need to find that length. And you're like, wait, that's not a special right triangle. And that's true. So this trigonometry will work on the special right triangles that we did last lesson, but it works on every single triangle. This is your universal remote control undo button and redo button. It works on everything. Special right triangles are the shortcuts that we can use in our head. These, unfortunately, we always need to have calculators. So you are going to be using your laptops to open and close and use that. Hypotenuse. The hypotenuse is which of these three lengths would we say? It doesn't really matter what my angle of reference is, but where is my hypotenuse? Quite raise hand. What's the hypotenuse? How would you describe it? Yeah, Andres.
The hypotenuse is the line that is slanted.
Yeah, so you want to think of it as like the diagonal line?
Diagonal.
Yeah, so you can think of it as the diagonal line. We'll write that. Diagonal line. Or alternatively, it is always going to be the longest line. So I'll put an or longest. And then you can circle the hypotenuse if you want. There's the hypotenuse. It's right there. Notice another property of the hypotenuse is that it's always across. And the word across in mathematics is opposite. So it's always opposite of the 90-degree angle. So it's always across from the 90-degree angle, or it's opposite of the 90-degree angle. All right. Well, let's actually formally define what opposite is. So before I talk about opposite, I'm going to talk about what an angle of reference is. What is your perspective? If your perspective shifts, it changes these two words. These words could possibly flip. So I'm saying, it's okay, respect your space. Keep your hands and feet to yourself. I'm going to say whenever I put an angle mark right here, that means that's where I am. My observing point, my perspective is here. Sometimes my perspective might be up here, and I can be looking down on the triangle. So your perspective can change. So my angle of reference is wherever I'm standing, essentially. So if my angle of reference is down here, I'm looking here at the triangle, my opposite is going to be the thing that is all the way across the triangle. So you want to say the length farthest from the angle. And if you don't like the word farthest, you can say it's across from the angle. And then we can circle that one as well. So our opposite in this case is right there. And then finally, the adjacent. Does anyone know a synonym, another word for adjacent? With the quiet raised hand. Yeah, Andres?
Next to, or like.
Yeah, adjacent. Let's go ahead and just write the word next to. So if you're flaunting your language and you're talking to your parents, you're like, our adjacent neighbors were quite noisy last night, and you would be talking about your next door neighbors. So you can use adjacent in the real world too, but in mathematics it means something very specific. So if my angle is right here, adjacent, it kind of means hypotenuse, right? But it's not the hypotenuse, it's the leg that is next to the angle. So there's our adjacent. And if you don't like the word next to, I guess you could think of the word neighbor. That helps too, so neighbor. All right, so let's practice labeling the adjacent, hypotenuse, and opposites are abbreviations, by the way. Whenever I do hypotenuse, I'm just going to do the first 3 letters. So HYP for hypotenuse. We'll say OPP for opposite and ADJ for adjacent. So that's how we can label this diagram a little bit faster without writing out the whole entire word. And trigonometry is the unit of abbreviations, so that's a good little intro. All right, so if my perspective now changes to the top right, what is the hypotenuse, what is the adjacent, what is the opposite? Go ahead and label those now. If my perspective is right here, what is the hypotenuse? What is the adjacent? What is the opposite? Label them in your notes. Then check with the neighbor. Did your neighbor get it correct? Did you get it correct? Did you get the same answers as your neighbor? Did you get your same answer as your adjacent partner? Andres, make sure I can see your ears too, please. Thanks. All right, I need a quiet raised hand to stand up and point to each 3 parts and tell me what they are. It's not going to be Andres. He already has his card in. Although you don't have your card in, but your card should be. You cannot make the amazing shot. I can come take the card from you, though. All right. I'm going to have to cold call on someone. Cohen, thank you. Go ahead and stand up. Point to the hypotenuse first. All right, good. You're correct so far. Hypotenuse, and then you got a 50-50 shot if you're just guessing. Let's do whichever one you want to do. Do you want to do opposite or adjacent?
Opposite.
Okay, opposite. Which one is opposite? You are indeed correct, and therefore by process of elimination, Cohen tells us that the adjacent is right there. Thank you, Cohen. Yes, Andres.
Wouldn't it be the other? Wouldn't it be in vice versa?
It isn't. So if my angle of reference is up here, what is the closest, the neighboring leg of this angle? Neighbor or next to is this length right here. So this must be the adjacent because it is next to the angle of reference. And opposite of that angle, all the way across from that, opposite is all the way across from that angle. So this is our opposite.
Because I saw like the examples we had on top, and I thought the second longest side was the.
So
adjacent.
the opposite and adjacent, they could be switched. The adjacent is not always the longest or always the shortest. It's always next to the angle. It can switch there. So let's try it again. On the bottom right down here, let's go ahead and label this one on our own and check your neighbor when you're done. Label it opposite, adjacent, hypotenuse. And then check it with Mr. Sindel. Give me the thumbs up or thumbs down once you check it and you got it correct or incorrect, just so I can get a poll of what's going on. Nice. Looks like everyone's getting it. All right, let's move on to actually doing the trig function. So, this is an abbreviation. I told you it's a unit of abbreviation. So, SIN, I don't pronounce this sin. I pronounce this sine because that is what it actually is. It's spelled S-I-N-E, but I abbreviate by cutting off one letter and saying it's sine of this angle theta. And again, this angle is called theta, so if I come out to the notes here, just for us, this angle right here is called, in quotes, theta. It is a Greek letter. We usually use Greek letters in geometry whenever we're talking about angles, and you can't see it because the green screen is up, but I used to have all of the Greek letters, capital case and lowercase Greek letters behind that green screen. Greek letters are nice to know, especially the capital letters, because when you go off to college and you're talking about a fraternity or a sorority, you're like, oh, did you check out A Phi O the other night? You're like, what letters are you talking about? A is alpha, and then phi is phi. Pi is, which I always get phi and pi mixed up. So knowing your Greek letters is kind of nice when you go off to college. I'll try to teach you as much as I can. So cosine is C-O-S. I pronounce this cosine, not cos or cos. So this is cosine. And T-A-N, I pronounce that tangent, not tan, but tangent. So I read these sine of theta, cosine of theta, and tangent of theta. Has anyone ever seen these before with a quiet raised hand? You have? Gunnar, where have you seen these?
Calculators.
Calculators, okay. Andres Cohen?
Avid.
Avid?
What else I've seen them?
Avid. What do you mean by avid?
We did like these types of problems in Avid.
Oh,
like
yeah.
some related to this.
Yeah,
kind of-
because we did this like thing where we helped each other out on questions, and some of our engineers did problems.
Okay. So you've seen living proof that you'll be doing this in your next class. Yeah, Sergio.
Have you seen tangent before?
You have or you?
We like
Have.
Okay, nice.
I've seen it on MathWeb.
Una pregunta.
All right, so let's go ahead and write down these ratios. So these ratios you will have to memorize and commit to memory. The sine is the opposite, and I'm going to abbreviate here, opposite over the hypotenuse, which means sine of theta is always a fraction. It's always a ratio. All of these are ratios. They're trigonometric ratios. And I should have said that from the very beginning. This is the study of trigonometry, and these are trigonometric functions. And that is a mouthful to say. Even I sometimes have difficulty saying it. I'm going to write it off to the side notes. Trigonometric. Trigonometric. That is a trigonometric function, and it evaluates to a trigonometric ratio. All right. Cosine. Cosine is going to be adjacent over hypotenuse. Adjacent divided by hypotenuse. And finally, tangent is going to be opposite divided by adjacent. And last year, I did not do a good enough job of emphasizing what this was really doing. So, I don't know what my size of my triangle is, but I do know one thing, that the ratios, whenever I have a certain angle here, as long as I have 17 degrees or something, every 17 degree angle here means I have, what is that going to be, 63 degrees here. I know that this is now going to be a similar triangle. Whenever I know this angle here, I can find an infinite number of other triangles that are similar to the angle, or similar to the triangle that I'm talking about. So visualize that. Say, pick a number. Okay, I picked 43 degrees. Since I have angle-angle theorem, I can find an infinite number of other similar triangles to the triangle that I'm talking about. So once I just choose one number, one angle, and plug that angle in, I'm saying, oh, I can find the ratio of the opposite to the hypotenuse every single time. It's the same ratio every single time. I don't know what the lengths are, but I just know that the ratio from here to here is going to be just the opposite over hypotenuse. So when I'm saying sine, I'm really saying, hey, I know the ratio of those infinite number of similar triangles. It's this really weird thing to think about because you're not really plugging any numbers in. You're just saying, I can figure out how much bigger this one is percentage-wise than this one, or vice versa. So these are just fancy ways of saying, oh, I can find this divided by this, or this divided by this, or this divided by this. Again, inverse trig functions, I can go backwards, but they're just fractions for similar triangles. Gunnar.
Why did they use beta on those instead of something else? Like,
I could have used alpha, I could have used beta, I could have used a bunch of different Greek letters. Typically speaking, beta is your default to go for whenever you're talking about an angle. All right, so how are you going to memorize this? I will give you a memory trick to remember this. And it is called Sohcahtoa.
Sohcahtoa.
Sohcahtoa. Sounds like maybe a Native American name,
Sohcahtoa.
or it kind of sounds like suck my toe, but here it is.
Oh!
I'll get out my gross toes. Don't bite it off so I don't turn into Mr. Warner. This is how I spell Sohcahtoa. Notice that when I write so, I'm writing S-O-H because sine is the opposite divided by the hypotenuse. Ka is C-A-H. That's cosine is equal to the adjacent divided by the hypotenuse. And finally, T for tangent is opposite divided by adjacent. And if I read that thing out, it's Sohcahtoa. Sohcahtoa. This is your way of remembering your three basic trig functions. And there are more trig functions, but they all stem from a triangle, so they come in threes. There's also cosecant, secant, and cotangent. There's a bunch of other ones. There's inverse sine, inverse cosine, inverse tangent. Andres?
Is this like PEMDAS?
No.
It's kind of similar to it.
I mean, it is an operation using parentheses, so it falls under the P for PEMDAS, if you're wondering where it falls in that rung. All right, can everyone remember Sohcahtoa? Everyone, let's say it like 5 times so we really memorize it. Sohcahtoa. Sohcahtoa. Say it 5 times. Sohcahtoa. Sohcahtoa. All right, let's use it. Let's see if we got this. Again, it's just a fraction. Whenever I'm saying sine or cosine of or tangent, I'm just talking about a fraction. So, what is sine of my theta here? Well, I know that sine of my theta is with a quiet raised hand. Don't look at your notes. Try to remember this. Sine is so. So it's what over what? Who has their card still? You have your card? What is sine? It is opposite over hypotenuse. Good job. And then we have to go back and remember what is the opposite and what is the hypotenuse when I'm talking about this angle of reference. That's my perspective. So opposite means across. So all the way across divided by the diagonal hypotenuse. So what is sine of theta? What fraction is sine of theta in this case? Give me a quiet raised hand when you know the number divided by number. What is the opposite divided by hypotenuse? Cohen.
15 over 17.
Done. 15 over 17. It's that easy.
That easy?
That easy. Let's try another one. Cosine.
Wait,
And I should be moving these
way
up a little
too
bit.
fast.
Sohcahtoa. So A-H. Sohcahtoa. So what is cosine? Without looking at your notes, try to not look at your notes and just use Sohcahtoa. By saying that out loud, you should be able to know cosine is what divided by what, Jenny?
Adjacent over hip top.
Adjacent over
Hip top, whatever that's.
hypotenuse. Say it one more time.
Can we say?
Say it one more time. Hypotenuse. There it is.
Hypotenuse.
And then someone else, what is the adjacent? What is the hypotenuse? What is our fraction, Jose? 8 over 17. Again, whenever I'm talking about a trig function, I'm just talking about a fraction, a ratio. And then finally, tangent is what fraction? What over what? Sohcahtoa. Toa. What does toa mean? Let's talk to Josie. Oa, so O-A, opposite over adjacent. Perfect. Did you want to do the numbers as well? Or did you want to give that to someone else? Say it? Yeah. So opposite is 15 and adjacent is 8. 15 over 8. Done. We've done our first trig problem. Woo! So exciting. All right, let's go on and solve some harder problems. Why are these things useful?
I don't know.
Why are these things useful? Because back in the day, you had these instruments that could measure how much tilt you had. They're called inclinometers. And I can figure out exactly what percent raised I am, and I could be like, that roof needs to be this long. Or I can say, that mountain is this big, and it's going to take me 2.5 days to climb that mountain. It's very useful. Like, especially when it came to, like, think about, like, the gold rush. You're thinking, okay, I need to dig through this mountain in order to build a train to transport people during that area. How much time is it going to take me to burrow through that mountain? Well, I need to calculate how big that mountain is. How do you calculate how big that mountain is? You're going to use some trigonometry.
Or you can just.
So, let's think about this. I'm down on the ground. I use my inclinometer and I measure 27 degrees. Somehow I know that I have 6.8 degrees of elevation. I need to figure out how much distance I'm going to travel to actually hike up that hill. What are you going to have to do here? So first I'm going to set up a trigonometric function. What trig function relates these two values? You're thinking, okay, well, my angle of reference is here, so this must be the adjacent or the hypotenuse or the opposite, and then divided by this one. So first of all, let's label these. What is 6.8? What is our question mark in terms of opposite, adjacent, and hypotenuse? Someone that has a card still. Sorry, Gunnar. Someone that still has a card. Your card is in. No, her card is in too. You can't even use her card. Who still has their card?
I do.
Monse, you have your card. What is 6.8? Is that the opposite or adjacent? It is indeed the opposite. And what is the question mark? And my last question, Monse, is what trig function relates the opposite in hypotenuse?
Opposite over hypotenuse.
Yeah, opposite over hypotenuse is that sine, cosine, or tangent. So I see OH.
Sine.
Yes, sine, because it's Sohcahtoa. So I'm going to say sine is the one that I want to use, and I'll say sine of the angle. Remember, the angle always goes inside of my trig functions. And if you don't like saying the word trigonometric, just say trig. It's easier to say. So I use the trig function sine, and I plugged in our angle, and I say, hey, that's equal to the ratio of the opposite divided by the hypotenuse. We'll say hypotenuse is now x. Instead of question mark, we'll say x. So sine of 27 is equal to the opposite divided by hypotenuse, or it's equal to the 6.8 divided by x. So maybe I should rewrite these things in a different order so it's a little bit easier to see. I'm going to go like this. The opposite divided by hypotenuse is indeed 6.8 divided by x. And then I can solve. So when I'm solving, I'm kind of ignoring the opposite divided by hypotenuse, and I have this fraction of sine of 27 over 1 is equal to another fraction. Whenever I have a fraction equal to another fraction, I mean, there are a few tricks, but the method that will work every single time is to, what is this operation called?
Cross.
With a what are you saying, Andres? Yes, Hessica. Yes, so I'm going to cross multiply. So can you do this one for us? What is that? Just read them out together. Oh, careful. So it's 27 is inside the sign, so I can say sine of 27. And that's all multiplied by x. I'll put that x out front. That's typically where we put them. And then what's the other one? The other direction, Jessica? Yeah, 6.8 times 1 is 6.8. 6.8. We have now used a trig function. We set up our ratios, then we cross multiply, and then we're going to solve for x. Right now, x is being multiplied by this entire quantity of sine of 27. It's very important to think of this not as sine times 27. Sine doesn't mean anything on its own. Sine of 27 is a number. Think of sine of 27 as a giant block. It is, I can't undo the block yet, but right now this is just a number. Sine of 27 represents some number. So if I have some number multiplied by x, how do I isolate for x? What is the inverse operation of multiply by some number? Quite raise hand. What is the inverse operation of multiply by some number? Andres.
Divided by sin 27 or sine 27.
Yes, we're going to divide both sides by sine of 27. Divide both sides by sine of 27. And then our signs are going to cancel out, and I have the equation x is equal to 6.8 divided by sine of 27. And I just enter that into my calculator, and it says round to the nearest hundredth. Hundredth means 2 decimal places. So on my calculator, I'll go to Desmos.
What was that?
Oh,
Minecraft.
Something that Eamon shared with me. I'm going to watch it later.
Yeah, I thought that was Bernie, not Bernard.
Bernie?
Bernie Sanders.
Okay, so one important thing is when you do this problem on your Spotlight search, you will get the answer, but in a weird form. By default, your Spotlight search has radians. For almost all of geometry, we're going to be dealing with degrees. So if I type this in, it's not going to work, and I'll show you why it doesn't work. So 6.8 divided by sine of 27. We get an answer. It's just the answer that would happen if I was in radians. If I come back here and use, that's not, I want to do the calculator. I don't want a graphing calculator. I want the normal calculator. There we go. So if I have 6.8 divided by sine of 27, I get 14.78.
Oh.
Or 14.97. I can't read. Notice that right now I'm in degrees. I can switch it to radians, and I would get the same exact answer that I had back here, 7.11017. But our answer should be in degrees, so our actual answer should be 14.98. So this is equal to 14.98. 14.98. And we were rounding to 2 decimal places, so I rounded that correctly. It was a 7, and then since that's the second decimal place, I round up because the next value is a 5 or greater. All right, let's try one more. And then you're going to do example 4 on your own. So example number 3. The first question that I always ask myself is, what are these things that are being given to me? Is this the adjacent? Is it the opposite? Is it the hypotenuse? What are these things? With a quiet raised hand, who can tell me? What is 10? What is question mark? Label them. What are these things? Quiet raised hand. Who still is not in? Fernando, do you have your card still? Fernando, tell me what 10 is.
Hypotenuse.
10 is the hypotenuse, and therefore question mark is the adjacent. Perfect. So I need to find some trig function that relates the hypotenuse and the adjacent. Do I have everyone in here? Sergio, have you got your card in yet?
No.
Which one has it now?
Sergio. Okay, what trig function relates the hypotenuse and the adjacent? And you read it. A-H. So which is the Sohcahtoa? This is Sohcahtoa. Sohcahtoa. What letter starts with Ka? How do I pronounce that thing that starts with a C? How do I pronounce this?
Cuz.
No. Cosine, yeah. Yeah, you got it. So cosine of the angle of 32 degrees is equal to the adjacent divided by the hypotenuse. This is equal to our x divided by 10. And then I treat this cosine over 32 as a cosine of 32 divided by 1, so I have a fraction equal to a fraction. All right, next step. Quiet raised hand. Does everyone have their card in now?
Yeah.
Everyone has it in? Okay, yeah, first come, first serve. Gunner, go.
Cross multiply?
Yes. How do I do that?
Cosine of 32.
So cosine
Times 10.
of 32 times 10. I'm going to put that 10 out front. And then that's going to be equal to
It would be equal to 1x.
X.
Oh.
Oh. Look, we don't even have to do as much work as example 2. We're basically there. Let's just type that into our calculators. 10 times cosine of 32. Sometimes it's easy. So if I come back here, 10 times cosine of 32. The answer is, rounding to 2 decimal places, 8.48.
Wow.
So I come down here and say 8.48 is our x. Box it. Done. You guys now, I want you to try example number 4, and you are going to need your calculator, so please use your desmos.com/scientific to find that. If you want to use the calculators on here, on like the physical handheld calculators, that is perfectly fine as well. Once you do example 4 and you check it with at least one other person, you may begin on Khan Academy. All right, I need some volunteers. Example number 4, how do I set up this problem? Gunner, go.
Tangent of 70 is equal to 9 over x.
Beautiful. Yes, you set it up correctly. Next person, what do I do next? Sorry, not Sergio, I guess Andres.
You cross multiply.
I was just going to randomly call on you. Cross multiply, go.
It's gonna be x times the tangent of 70
X times tangent of 70
equals 9.
equals, cross multiply the other way, and you get 9. Thank you. And then finally, last step, Sergio this time.
That's where I got stuck.
So this is just a number being multiplied to x. So do the inverse operation of multiply by that number.
Divide.
Divide both sides by tangent of 70, yeah. Perfect. And then our tangent of 70, those are gone, and I'm left with x. I'll write this a little bit to the left because I'll have to do a decimal approximation. X is equal to 9 divided by tangent of 70, and I come to my calculator and I say, what are you? I say, it was 9 divided by tangent of 70, and I got 3.2, and then I'm going to round here to 8 because that's 5 or greater. 3.28. 3.28 and box it. Cool. Guys, give me a fist of 5 really quickly on our objective today. How well can you do problems like example 1 and problems like example 2, 3, and 4? 4, 4, 4, 4, 4. What is that, Sergio? Just do whole numbers so I can read them faster. 4, 5, Gunner. 4, Monte 5, and 4. All right, thank you.